Hello everyone, welcome to the next session on ANSYS Workbench tutorials. In this session, we will analyze a hollow rectangular column which is made of concrete for its compressive test. We will start by double-clicking on static structural module. Next, we'll go to engineering data. Here we'll create the material concrete M30. I'll first give the property of density, which is 2300 kg per meter cube. Next property is of isotropic elasticity. I'll give the value of Young's modulus in megapascal, which is 25. Poisson's ratio is 0.18. Also, I'll give the value of compressive yield strength in megapascal, which is 30. Then I'll go to project and update project. Next, I'll go to geometry and right click, new design modular geometry. I'll first go to units, millimeter, XY plane, look at. I'll go to sketching and choose rectangle as option. We'll draw a rectangle and give its dimension. The value of H1 is 100. The value of B2 is 50. L4 is 25. And L3 is 50. So this is placed exactly at the center now. Again, I'll go to draw and choose rectangle. I'll go to dimensions again and give the dimension. H5 is 80. L8 is 40. L7 is 40. And V6 is 20. V6 is 40. This value is 20. So once we have created two rectangles, we'll go to modeling. I'll choose the extrude option. I'll select the sketch one. Apply. The depth will be, say, 3 meters, so it is 3000 mm. I'll click on generate. Now I'll close the screen. I'll go to model and double click. I'll go to geometry and select the solid. I'll change the material to concrete M30. I'll go to mesh and generate. You can make a finer mesh. I'll leave it to this coarse mesh itself. I'll go to static structure, right click, insert, pick support. I'll choose the face option and select this face. Apply. On the other face, I'll insert force. I'll change vector to component. Along the z-axis, I'll give a load of 8000 Newton. Next, I'll go to solution, right click, insert deformation total. Right click, insert deformation directional. I want to see the deformation along the z-axis. Right click, insert strain equivalent and stress equivalent. Then I'll go to solution and solve. First, we'll see the result of total deformation. We'll hold this straight up. We can go to edges, select no wireframe, contours, smooth contour, such that the colors blend into each other. We can animate and check the result. You can see here the maximum deformation is 533.35 mm, which is 53.33 centimeter, which means it's quite a deformation at the top end. So you need to reduce the value of force. Next is the directional deformation. Again, since it is z direction, the value is almost the same of highest value of deformation. Next, we'll go for the value of strain. Highest value is 0.1828. If you want to see where it is max, you can click here. If you want to see where it is minimum, you can click here. Then we'll go for the equivalent stress. Maximum value is 4.56 megapascal at this end, and minimum is 3.66 at this end. Now deformation maximum is here, which is quite a high value, and the value of stress over here is quite less, because we have given the yield strength of concrete as 30 megapascal, and this is just approximately 5 megapascal maximum. So it is 1/6 of the yield value. So the load bearing capacity is there, but at the top end what you will see is deformation. It is just that the length is too much for this column, so you will have to increase the dimension such that it becomes more stable under this length and loading. So you just need to increase this thickness over here such that the value of Z is enough for this cross section. You can change the cross section and make this column stable. Also, you can change the load if you want. If you don't want to change the cross section, maybe if the constraint is with the cross section, you can change the length, or if you can change the material, that is also well and fine, which will have a better yield strength. Or you can shift to what we will discuss next, which is CFST column. So there are many other options also available if the constraint is of dimension or load or the length, something of that sort. So you can just go about with what is variable and you can change that. With this, I end the session. I hope you have understood the analysis. If you have any doubt, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.